Hello and welcome to our video on setting up a multi-run simulation for a single zone with 8 ICDs. This is an essential step for generating pseudovalves through regressional analysis, which can be used in Insight, multi-zone, or reservoir simulators to simulate the behavior of an entire well. A pseudovalve is a representation of an entire zone which incorporates the effects of oil, water, and gas segregation, as well as valve interactions. We'll continue our simulation in single-zone, multi-run application. If you haven't set up a single-zone simulation case yet, be sure to refer to our previous video. Click on the single-zone icon, then open an existing project. Select an existing single-zone simulation project folder, and select the model.json file that we generated in the last video. Click Open. The case will load and redirect you to a single-zone simulation window. Before we create a new multi-run case, we can preserve our single simulation case in its original format. To do this, we'll create a copy of our project. Click on the File menu in the top left corner of your screen and select Copy Project. This will allow us to work with a new project while keeping the original intact. Insight will propose a name for the case based on the existing name. We rename the case to Demo ICD-MR and click OK. With our project successfully copied to a new directory with a new name, we're ready to make some modifications in the solver section. First, we select multi-run for the regression instead of single simulation. This will enable us to generate pseudovalves through regressional analysis. You'll notice that the path to the new project directory has automatically been selected and is displayed in the current path information box. Select the number of CPU threads to be used under the multi-run options. You can check the number of cores on your computer by opening the Task Manager. Go to the Performance tab and the number of cores will be displayed. I have 8, but I will use 6. Moving on to the boundary conditions, we'll keep the pressure boundary conditions and select min and max values. For this simulation, we want to predict the behavior of our system for different outlet pressures, ranging from 175 to 195 bar, using 4 points. It's important to ensure that the highest outlet pressure is below the reservoir pressure. Now we need to specify the number of volume fraction points to be simulated. In this case, we've chosen 9 points. This means that the simulations will be performed for a variation of 9 water fractions and 9 gas fractions, ranging from 0 to 1, for all 4 outlet pressures that we've specified. Once you've set up your boundary conditions and volume fraction points, click the Run Simulation button to begin the simulation. You will now be directed to the simulation dashboard, where you can track the progress of your simulation and access updated information and results. At the top of the dashboard, you'll see the progress bars that indicate the number of started, completed, and failed cases. As the simulation progresses, you'll have access to current, updated, and tabulated information and results for all cases being simulated. Any failed cases due to a lack of convergence or instabilities will also be indicated. And you'll have the option to rerun these single cases with other convergence criteria if necessary. We will go through that process in a separate video. During the simulation, you can sort the cases based on their status and boundary conditions, such as volumetric phase fractions. To do this, simply click on the funnel icon at the top of each column and choose your desired selection criteria. This feature makes it easy to filter and view specific cases of interest. During the simulations, you can easily inspect the results in a 3D plot. Simply select the desired water or gas fractions from the drop-down menu above the plot. If you choose a water fraction, the plot will show delta pressure through the valve system with respect to gas fraction and total rate. If you select the gas fraction, the pressure difference will be plotted with respect to the water fraction and total rate. Completed results will be indicated with a dark green color, while cases currently being simulated will be displayed in a light blue. Unstarted cases will appear as gray or brown. The 3D plot provides a visual representation of your simulation results and can help you identify patterns and trends in the data. When the simulation is complete, the status bar will read 100%, and a message will appear in the upper right corner. You can then plot the results on the right-hand plot area. Each point on this plot represents the stabilized results for a single case, as we covered in the previous video. Notice how these points create a surface. In the next video, we will create an equation for this surface using regression analysis. Once we have the equation for the surface, we can easily plug it into reservoir simulators or Insight multi-zone. This will enable the program to include the effects of fluid segregation in the wellbore, along with the complex effects of valve interactions. This video tutorial provides a step-by-step instruction on setting up a multi-run simulation for single zone with 8 ICDs in order to generate pseudovalves through regressional analysis. The tutorial covers how to create a new multi-run case, modify the solver section, set boundary conditions, and run the simulation. The video also shows how to use the simulation dashboard to track the progress of the simulation, sort and filter cases, and inspect the results on a 3D plot. The next step is regression analysis, which is covered in the next video. Thank you for watching.